Hello, welcome to the 10th video outlining my software as a service project. In today's video, I'd like to delve into my Tenant API and just what I have so far. I'll walk through the code, discuss key architectural decisions, and I'll refactor anything that doesn't sit right. This hands-on video will help reinforce the concepts we've explored so far, like single responsibility principle, dependency injection, and repository patterns. So in the last video, I discussed CI, CD, continuous integration, continuous deployment, and why we need to consider it at the start of a project, and the benefits to having automation in place. And these first 9 videos, they delved into my design and technological decisions, the software design and architecture patterns that I would be following that I felt were necessary to start the series off with. For me, it helped set the stage, and I hope that it gave you enough background information as to the decisions I made. So with that out of the way, let's take a proper look at the code base. So the Tenant API, it's a core part of my SaaS platform, handling multi-tenancy at the database level while enforcing strict data isolation. So let's take a look at how this is structured, starting at the entry point, program CS. I make use of top-level statements. These were introduced in .NET 6 to simplify the entry point into our applications, as we can do away with the static main class evolve. So this removes a lot of boilerplate code, making it easier to read and maintain. It also simplifies application startup while keeping everything concise. So as I scan down the files, so you can see I have set up some login to console, and some mapping sites I did previously have it deployed to Azure, and my Swagger generation. And then I set up my dependency injection and the method called add my services. So we see I've got my tenant provider and my interface. This is how I ensure that my user accesses only their tenant data. The tenant ID is read from the JWT token. Yeah, so it's read out of claims. And that's provided in a request from a working tenant claim stored within the token. My database context access for tenant provider via dependency injection, and sets a private variable. To the GUID that I pull from the provider interface. I've got some global filters as well on my context that ensure that the tenant ID is provided in every query. And we also I've got a condition so that I exclude deleted records by default via the soft delete mechanism I've implemented via the iDeletable interface. And I have these as two separate interfaces. Some entities may not need to be tenanted. And this is an example of the interface segregation principle that I've discussed in video 5, solid principles and design plans. I also set up the services and repositories that I need, and these are scoped to the user's thread. The Squid service is a singleton, as this just handles validating, encoding and decoding squids, and these aren't persisted. I've then got extension methods that set up my database context. No auth, automapper, and some application settings. Yeah. And I've got a global exception handler as well. Right. So when I have my controllers, I set up two model binders and ensure that all the controller endpoints are behind authorization. So without a valid OAuth token, requests to this API should be denied. I've got a piece of code here that applies my database migrations. And for now, this will suffice. But before I can scale out my hardware, so yeah, I have this piece of code that applies my database migrations. And for now, this will suffice. But before I can scale out my hardware, this will need to be ripped out and handled by my deployment pipelines. And finally, I have two middleware components. One decodes squids, and the other uses those decoded squids values to fetch squids from the database. And this currently results in up to 3 database calls per request, and that's clearly not ideal. So we'll refactor that shortly. Eventually, I'll also introduce caching middleware to avoid hitting the DB on every request. If the income request already contains GUID directly instead of squids, this middleware will simply parse them in the request context, no lookup needed. So if squids are not valid, then parse. And if you remember from my earlier videos, I specified that I wanted the ability to use squids and GUIDs to access my APIs. I use the single responsibility principle to separate out the decoding of squids from the lookup of GUIDs. This ensures no matter how my API is consumed, whether the URL consists of squids or GUIDs, the request is processed correctly and consistently. So that's the high-level structure of Program CS. We've set up DI, authentication, exception handling, multi-tenancy enforcement. So now let's look at the controllers. So the first control is my tenants controller. This accepts my abstraction for the tenant service and the abstraction for the HTTP context accessor. This allows me to keep my controllers thin. I currently only have the one method. So this method reads the GUID from the HTTP context. This is the value that was set in the middleware I just showed. I guard against an empty GUID. And return a bad request with an error object. Otherwise, I call the TenantService to retrieve the tenant details. I pass along the cancellation token and the tenant ID. And the reason I pass the cancellation token is that this sits my persistence layer. If a request is cancelled, I would rather not waste resources by reading from my database when the request has been ended by the consumer of the API. If I follow pardon me, if I follow the method into my concrete implementation of the tenant service, you can see it takes a repository abstraction and the IMapper abstraction from the AutoMapper library. My service calls into the repository to retrieve the tenant, and then using AutoMapper, it projects from the entity, which is tenant, to the tenant DTR, and then returns it. You can see we pass a cancellation token into the first or default, and this is when the query is executed. So if I follow into my repository, you can see in my concrete implementation that I return an iQueryable of tenant. And this is the data access pattern that I am choosing to use. The idea is that I build up my query in my repository. So all querying logic resides here, and I pass the queryable back out so that I can add further conditions to the queryable in the application services layer, such as paging, filtering, and sorting. So maintaining the separation of concerns between my query and logic, such as filtering and paging, that can sit closer to the application that drives these needs. This is deferred execution, and the database isn't hit until the results are actually needed, which happens in my application service. So the locations controller uses the same patterns. The controllers are again kept thin via relying on the service abstraction. The only logic in the controllers is to determine the response. Okay, bad request, not found. This has two methods. One to get all the locations for the tenant, and one to get location by its ID. So those of you who are eagle-eyed may notice that this will pull everything, so we don't provide any paging mechanism. This is deliberate for the moment. It's what's known as YAGNI. or you ain't going to need it until you need it. I'm going to quickly switch to my Mira board. And at the moment, you can see we've got 3 tables. However, in future, I will want to allow locations to have locations. So, for example, if a management company covered the whole of Yorkshire, they would have locations for North, East Ridings, West and South. Within West, they would have Bradford, Leeds, Harrogate. In the South location, they could have Sheffield, Rotherham and Barnsley. So when I'm ready to have this feature, I will need to have a parent-child relationship within the location table. But as of now, I will only be testing my software in the one site, in the one location, for the one tenant. So it's Yagni for now. If we follow this to my repository, we can see that I need to modify my might get location by ID method to return an iQueryable. So if I follow this pattern. And then finally we've got my sites controller. This has 3 methods. So get all sites for a location. Get site by ID. And a method that will get working tenant details. And again, it follows the same patterns. However, in my service, I've added as no tracking to the queryable. As these are all reads, I don't need the overhead of change tracking. This should ensure that the operation is most efficient, and I should add that to my previous 2 services where it's applicable. So I think now will be a good time to fix some of the issues that I've found, and that will bring some exposure to the unit tests, which I can discuss in further detail, as I will be writing the test before the code using TDD. So I will leave the database migration code I identified in the program CS class for now. Remember Yagni. At the moment, I don't need to separate it out into the pipeline. Software development often requires us to make compromises. I know it's not ideal to apply my migrations this way, but I don't need to worry about extracting that code until I need to scale my hardware out. And as that is a fair way away, I can focus my efforts elsewhere. If I tackle my technical debt when it's appropriate, or as part of a future feature, then I shouldn't suffer any issues. If I ignore my technical debt and find I need to scale out, I won't be able to do that until I make it part of the deployment pipeline and that will cause me pain as I can't react to the needs of my application. And this could cause the user experience to degrade as I would be unable to scale my resources to meet demand. So as we're aware of this, for now we can Yagni. I did identify that my middleware wasn't efficient. One of the repository methods wasn't following the pattern I have chosen. So let's begin with the middleware first. We won't worry about the caching for now. I need to decide how I want to handle that. Do I go for in memory, or do I look to Redis for a shared cache, or do I want a combination of both? However, I can fix the inefficient querying, so let's do that now. Okay, so here we can see my test class for the middleware. It's the same name of the class, but with tests appended to it. Long ID, GUID lookup middleware test. Naming my test classes this way helps me to keep my code organized. This way, I always know what my test file will be called if I quickly need to jump into it. I have two tests. One that tests if I pass in GUIDs, that it correctly sets up my HTTP context. And one that tests if I pass in squids, it looks up the value from the database. If you recall, I have two middleware classes. The first is the squid decoding middleware, and as the name suggests, it will decode any squids that come in and place the decoded long value into the HTTP context. If the values aren't valid squids, then the middleware calls the next method, which will invoke the next component in the pipeline. In our case, that is a long ID to GUID lookup middleware component, which is what we are testing. So the first test will provide GUIDs and check that they are correctly passed into the HTTP context. The second test provides squids and then checks the loader from the database correctly. I've also noticed a couple of things as well in the code that needs to be changed, which will make this a lot easier to test and we get our separation of concerns. So the main issue in this class is that I am injecting my database context. This isn't easily mockable, so we need to separate this out. I have an Azure function that also reads from the same database and provides the GUIDs. And this is required for the other APIs that need to access these values that don't have access to the underlying database. When I cover the function, you will understand the need for it. So with that in mind, you may be asking why I don't utilize the Azure function. for this API? And that's a good question. The reason why is because this API has direct access to the database, so a little bit more responsive and efficient over calling out to the function to get these values. What we'll need to do is check how efficient the repository does its querying. And if that's suitable, we'll pull the repository and likely the service code into this API, and then share it via the NuGet package so it can be consumed by the function. And then lastly, in my tests, I have some extension methods. I use to set up the route path, the route values, ensuring that the mock context is correctly set up for the needs of the test. I should probably create AutoFixture customization for these so that I don't have to arrange inside my test. We shall aim to fix this too. So looking at the service and the function, we just care about this latter half. The decoding of the squids is handled by the middleware in our API, and we are focused on the database querying and making that efficient. So the code looks good. First glance, we retrieve from the repository and then use Automapper to get our DTO. And then let's check the repository to ensure that we're happy with the formation of the query. And this method builds a query, and it will include the location if it's provided. And this is the method that we need to pull into our API. And once that is done, we can clean up this as your function to use a new method. I won't be doing that in this video, but I will save it for the video focused on the function and its reason for existing. So back to our middleware. We can see that we would only have to modify the function slightly. Modify the function method slightly to allow site to be nullable in the query. Sorry. So we'd only have to modify the function method slightly to make site to be nullable in the query. Our URLs could only contain the tenant, tenant location, or tenant location and site ID. So we need to cater for this in our reworked query. Uh, so, doo-doo-doo. Oh, looking in the infrastructure library, we can see 3 repositories for the entities. And I think the tenant repository is a good fit for this method. It's getting tenant identifiers, and the minimum we need to provide is a tenant ID. The Azure function makes use of this concierge management.infrastructure library too. So we know that this refactoring appears to be fairly safe. And we can access the repository reusing our query in the function. Yeah. So let us open the tenant repository and begin. So here we are. So we'll need to modify our repository, both the interface and the concrete class, so that the new method is available to our code. But before we do that, let us first amend the existing test. Sorry, that's where I am. So we're now going to rely on the TenantService interface. So our test will need to have setups and verifications against this interface. And this should allow us to ensure we are testing what we need to. So for some reason, I have placed my services in the wrong layer. They currently sit in my API layer, when in fact they should reside in my application services layer. We will correct this later, as I am taking a test-driven design approach to my development. We first modify the test. It won't compile, that's fine. But defining the test correctly will help to drive how we write our code. So firstly, I will modify the test method signature by removing the injected management context. And we've determined that we don't want any data access in our middleware component. and we have taken the correct decision to abstract this away and push it to the correct layer we have identified in the onion architecture pattern. As this is no longer needed, we can remove it, and now I've got compilation errors, but that's okay. We no longer need the DB context method. So I will remove this, and then this was the only usage of that method. So we'll remove this as well. So we need to inject the TenantService interface to the test, and then pass this into the middleware. So first we have the interface to the method signature, and then we replace the management context variable in the invoke async method call with our new one. Service. So before we modify our middleware component so that the code compiles, we'll first make sure we're making the necessary verifications against the service so that I can assert on the correctness of the SUT. What we have assertion-wise is still correct, but we also need to verify that the method on the tenant service was called. So let's now have this before fixing up the middleware so that the code compiles. So as the method doesn't yet exist on our tenant service, we again have non-compiling code, and what we're doing is shaping the code via the test. So I'm going to assert that my service received one call to a method that I'm going to call getGUIDs for, that takes 3 inputs of long. Tenant.id, ID. And now it'd be a good time to fix our code. First, I will add the method to the service. I am using ReSharper to do this. I want my new method to return a task of management GUIDs DTO. as this will be an async method call, as it's interacting with the database somewhere in its chain of dependencies. I also want location ID and site ID to be nullable. The minimum I should receive is a tenant ID in any request to the API. And I will now jump to the concrete type. Oops, and add the new method. I'm not going to write any code for this just yet. We will write tests for this shortly in the TenantService test class. Finally, I inject the service into the middleware, fixing my last compilation errors by passing along the tenant service. I'll pass this along to the method. Yeah. And before we fix this code, if I jump back to my test, you should see that my errors now disappeared. So back to the test. I still need to pass my longs from the HTTP context. Oh, sorry, back to the yeah. So I still need to pass my longs from the HTTP context. So I will move these variables. Just bear with me. So I will move these. Up here. So move these variables that capture the location and sites at the top. And then I will move the try parse out of the if statement. And I'll repeat this for the other two calls. So I'm going to say this. And then that's it here. I also want to capture when right, so I'm just going to do exactly the same here. And Right. And we can pass these into the services method call. So before we do that though, we need to see the test fail. Um, so for now, I'm going to comment out the if statement. We may need these later. So just wait for this one to start. Oops. Looks like I've got some. These are some extension methods that I use. That I renamed that forgot about. So I should build now. Yeah, and should be able to run the tests. So as we expected, the test fails. Expected to receive a call. And it seems silly, as we knew it would fail, as we haven't called the method on the service, and we have this assertion. However, if we don't see the test fail, how can we be truly positive that the path we are seeing is correct? So now that we know it fails, we need to add our method call to the code. um, so I will need to capture output from the method call, and I will pass in the pass values, and I can set the tenant ID in the HTTP context using the tenant ID and the management goods variable. So um, pass location ID, pass site ID. So to modify the remaining two if statements. I'm going to capture whether the try pass succeeded. So I'm going to call this location present and site present. So I will um, move that in this one. I will check if location present and and if so, we set the variable in the context. And then we repeat this for the site variable if it's present. These could be null. So run the test. I can see that it still fails. The values we are asserting don't match. And what I've forgotten to do is set up the mock service to return an object with known outputs. So to do this, I tell him substitute what I want it to return when it receives specific inputs. So just bear with me. Right. So So I'm just going to use args.isLong. One. That's it. Sorry. Sorry, I'm just trying to look at the reference. I want to find it out. Sorry, I'm going to use arg.any. So this predicate will take returns. So the value matches the tenant ID, location, and site ID. Sorry, I do want args. Args.is long and I want to have a predicate that checks the value matches the tenant ID. And for location, bitframe. And in my returns, I construct the DTO using the external identifiers of the tenant site and location that AutoFixture injects for me. So if I run the test now, we should pass. And I get a green. Test. But now my test consists of a range code. And I also need to test the code when site isn't provided, along with a test for when site and location aren't provided. So I want to move the arrange code first. So I'm going to create a new composite customization that will ensure the squids are set appropriately for the test. I'm going to call this One ID, middleware, tenant location, and squid composite customization. It's a bit of a mouthful, but it is explicitly named, so we should understand what this customization is doing. Um, and, and then I'm going to move the arrange code from the test into its own customization. So let's create the customization first, and I will call this squid tenant location and site customization. It's public. Um, so I'm going to then get n substitute to provide me a mock squids encoder. I call it fixture.freeze, and I will new up a a new default HTTP context. So I'm using freeze to ensure that I get the same instances of types, pardon me, across the test setup within the test itself. So I will move the the extension methods here from my test. Put in here. And finally, I inject my HTTP context into the fixture. And in the test, I will change the type in the customized fixture attribute. The new composite customization we need to complete. Yeah, I'm passing in my customisations I need as part of this. And I'm just basing this off of the old one I meant to rename. So I need to bring these on. To this one. Oops, well done. Cut and paste error. And I need to provide my new squid tenant location and site customization. When I now run my test, I can still see it passes. I've still got a range code in my test that I need to shift into the customization. So first we'll move the the context items setup code. This. So we'll move that. But now I need a tenant location and site. So I will ask the fixture to provide these for me. And I use freeze. And that allows me to remove the redundant code. And then finally, I need to move these to setup calls to my services into my customization. I'm going to need instances then. Again, that should be that. So when I look at my test now, there's no more arrange code. I just call this up and invoke the method, and then I insert on the outcome. So now I need to repeat that process for the other two tests. Right, where am I? Right, yeah. So need to create a test. So I apologise for the silence. I trying to follow my notes. And we're going to call this task. We're going to call it invoke async given tenant and location squids in root path. Sets item in HTTP context. I think actually we'll rename this as well to invoke async given tenant, location, and site squids in root path. Sets items in HTTP context. This one. Need my customization. Right. Right, where am I? That's a leave that for now. So we require the same inputs as the previous test, except for one value, the site. So take these. So when we verify that the service was called with the expected inputs, we just pass null for site ID. The assertions are virtually the same, except this time I want to check that the site is null. I think I've named that one wrong answer. Yeah, this is the one. Apologies. So we need as input all the same, except this time we don't want sites because we're going to pass null through. So I want to wait and take these. So we invoke it. So we'll call with a null. Ensure that site ID is null. Those others match. So now I'll create a new customization class called called Squid Tenant on Location Customization. Customization. And then we'll add this to the customize fixture attribute. And run this to see it fail. Now that we've seen it fail, we need to add the customization code. And this is virtually same as the previous customization. Except I call add tenant and location squid base route path. Instead of this one. HTTP context. So manage nugget package. Import the extension method. So yeah, virtually saying so these different and our assertion is any null in site ID, but the tenant ID and the location ID match, and our object would have an empty grid We can now run the test again, and it should pass. However, it doesn't, because my code uh, uh, it's incorrect in my middleware. So let's add a breakpoint and debug the test and see what's going on. So as must have copied and pasted something wrong from somewhere. So much for planned. Right, this is wrong. Oh. Tenant ID should be there. So it's debug. Right, yeah. There should be numbers, that's good. There's a step in. What's happening there? Location. Oh, they're the squids, aren't they? Sorry. This is debug. So, no, as expected, context only contains 2 items. Oops. That blew up with a. Okay, not present in dictionary. And it's because I'm trying to read without checking if it exists. And that's causing the key not found exception to be thrown. So I'm going to make this more resilient by having it use a try get value method with an inline if. Oh. Right. So, down here. And choose try get value. I'll call this location. And then just the inline is if it's there, we've got location, otherwise it's null. And in fact, I've done that wrong. This one context dot try get value. It's a bit out there. Look at that item. I'm gonna do the same thing. Item, otherwise it's null. And I should not pass. Still don't pass. Right. The service verification failed this time. We expected site ID to be null, but we actually got it passed through a 0. And to fix that, I'm going to use another inline if. Yeah. So site present, site ID, otherwise no. This time my test should pass. And it does. So now I need a test that just passes through the tenant ID. So starting with the test, which we're going to call invoke async underscore. Sorry. So we're going to call it invoke async underscore given tenant squids in root path. So it's like in the HTTP context. So this time we want the same inputs but without location. Tables. And but we also want to verify that our call to the tenant service is with a null location and null site ID. So I will now create the squid tenant customization. We've got file scope it and make it public. So this is the same as similar to previous two. Only this time I'm adding the tenant squid to the root path and into the root values for my setup. Only setting in the context here, and my tenant service expects a nullable one, returning empty goods to simulate. So this. Customize feature. Of course, we need to see test fail. So yeah, we're doing that run test to see it fail. It's not going to fail yet. There's no code in it. So it is. Yep. I'm just going to bring this in. So same as before, we invoke, check the response, check our tenant service received the tenant ID and nulls, ensure that they don't exist in the context, and the tenant ID matches. So we can run this test. We see fail. That's because we've forgot to. Yeah, there's again. So I've not set anything. So I need to enable my customization code. We'll run this. And we see it fail, and same as last time. Keynote found exception. So we know how to fix this one. So same as we've done here. We try get value. out. Is it out file? Location. Location. Otherwise, it's no. And then the same happens here. Location present. Past location ID. Otherwise, no. And now it passes. So that's we've finished refactoring this aspect. And along the way, I managed to find a few code issues early, get testing for them. So now that is out of the way, we can complete the tenant service. Sorry, the tenant service. We got the tenant service. Tenant service test. And if we look, we've got no code. So we write the test first. So in tenant service test, create a new test. We'll call this create goods for given valid IDs, returns management goods detail. And this will need to take in a going to need to take in the tenant's repository interface and the tenant service sub. So these, which one let me get? So freeze this interface so they get the same instance passed through my test, allowing me to verify my repository method call. So I'm going to leave rearranging this code. I'm going to sort this offline and extract it to customisations. As I've shown you that process already. I'd like to finish the refactoring, but I have started. So with like mindless build the response from the repository. Again, I'm going to call this get goods for. And I'm going